So this is the Group 4 project. So, okay. What is ATP and why is it important? ATP, adenosine triphosphate, is a molecule that stores and transfers energy in cells. It consists of adenine, a nitrogenous base, ribose, a sugar, and three phosphate groups. The bonds between the phosphate groups hold high energy potential. ATP is an immediate and universal energy carrier. So think of ATP like cash in your wallet rather than money in the bank. It's meant to be spent quickly. Cells don't hoard ATP. They produce and consume it on demand, ensuring efficient energy transfer. Unlike stored energy like fats, ATP is always in motion, facilitating countless reactions every second. So ATP powers essential biological processes. So ATP drives key cellular functions such as muscle contraction, active transportation, and biosynthesis. The regeneration cycle, it's ATP. It's constantly regenerated through cellular respiration in mitochondria and photosynthesis for plants. The ATP-ADP cycle ensures a steady supply of energy, preventing depletion. So cells don't just burn through ATP and run out. They recycle it. The mitochondria acts like a power plant, continuously recharging ATP from ADP, using nutrients such as glucose. This cycle is so fast that a single ATP molecule might be used and regenerated thousands of times per day in a single cell. So, why is ATP considered the energy currency of life? Well, ATP it's often called the energy currency of life because it acts as an immediate energy transfer. Just like money allows transactions without bartering, ATP enables energy transfer without needing direct fuel sources. The key to ATP's energy lies within the phosphate bonds, which store and release energy when it's broken. Imagine if every country had different forms of money. Trade would be chaotic. Instead, ATP is like a global currency of four cells, universally accepted and instantly convertible into usable energy. It bridges energy production and consumption, making life possible at every level.
A similar ATP-like currency decentralized structure could work as it could make energy transactions more direct and improve the inefficiencies which stem from central banks controlling the money supply. Some of the blockchain technologies, such as cryptocurrency, which is already used as a currency in some countries, also aim for decentralization. So if we develop a decentralized platform which uses energy-based transactions, each unit of energy could be used as an exchange for goods and services without the use of a central control role which our current central banks hold. An ATP-like system could derive the energy from renewable resources such as solar or wind power, linking currency to sustainable energy production. If implemented, this could reduce the environmental degradation, as the economy wouldn't rely on fossil fuels, meaning that the energy exchange would be linked to the sustainable flow of natural resources. Our current electricity grids and energy storage technologies are much less efficient and decentralized compared to biological systems which ATP run on. Our society heavily relies on large scale centralized power generation and distribution systems, which frequently experience inefficiencies and losses. While the process could be similar to ATP's molecule, energy currency needs to be measured and standardized in order to be exchanged and valued across the different sectors like agriculture, manufacturing, and services. A reliable real time energy tracker, which measures the energy units, is required to ensure equitable distribution across all sectors, with the current lack of standardization in energy exchange showing a bit of a barrier. The economic transition to an energy based currency would require a complete reset and restructure of the financial systems. There would be a shift from financial model based on cash currency to a model which reflects real time energy flow, production, and consumption. Blockchain has the potential to enable decentralized exchange through individuals being able to trade energy units directly without centralized authority. The smart contracts concept could be used to automate energy based transactions and ensure that energy is consumed, produced, and exchanged in an efficient manner. Renewable energy technology, such as solar panels, wind farms, and microgrids, have had an increase in the ability to generate energy locally, with the potential to enable communities or even individuals to produce and trade energy directly. Smart grids have the potential to improve the feasibility through the use of digital technology, which monitors and manages the flow of electricity and assists to efficiently track the production and consumption of energy. Working with advanced energy storage solutions such as batteries, these technologies have the potential to enable localized, decentralized energy economies.
A mathematical analysis undertaken by a Japanese university demonstrated how ATP-ADP molecules operate decentrally, much like an efficient economy where production and consumption are dynamically balanced. This concept of decentralization within biological systems will be further discussed, but it allows for ATP to function as the energy currency of biological systems, fueling the three key functions of money as a medium of exchange, store of value, and unit of account. A medium of exchange facilitates transactions between parties. ATP is the primary molecule that facilitates energy transfers within cells and different cellular processes, inherently acting as a medium of exchange. Just as money enables interactions in our modern economy, ATP allows for biological chemical interactions between different cellular processes. A store of value retains purchasing power over time, allowing economic agents to save and defer consumption. ATP acts as a store of value by holding its energy in high-energy phosphate bonds, releasing this stored energy when it is needed. Whilst ATP is not used as a long-term energy storage, as this role is played by glucose and fats, it is an immediate short-term store of value, much like the role of fiat money in a bank account. A unit of account provides a standard measure of value, allowing for the pricing and comparison of goods and services. ATP serves as a unit of account by providing a universal standardized unit of energy that cellular processes can budget for their energy needs. ATP provides a reference point for cellular energy costs, ensuring efficient energy management as each process requires a known amount of ATP molecules. As discussed, ATP, ADP molecules inherently exhibit three functions of money. We will now consider how these traits of ATP molecules can be adapted to improve and transform modern currencies into ATP-like energy currency.
ATP and the gold standard. The gold standard in economics and ATP energy and biological systems. Despite their differences, both serve as fundamental mediums of exchange, one for economic transactions and the other for cellular energy transfer. The gold standard was a monetary system in which a country's currency was directly linked to a specific amount of gold. This ensured standardization, as the value of money was directly fixed to the gold held by the government, much like how ATP provides a consistent energy supply in cells where specific functions require a set amount of energy. Next is convertibility. Just as paper money under the gold standard could be exchanged for gold, ATP can be broken down and synthesized as needed, converting stored energy into a usable form for biological processes. Stability was another key benefit of the gold standard. Pegging the currency to a fixed asset ensured trust in the currency's value. Similarly, ATP acts as a reliable energy source, allowing cells to consistently perform vital functions. Now let's look at ATP as a medium of exchange and a store of value. The gold standard facilitated global trade through fixed exchange rates. Much like ATP, powers all biological processes by transferring energy. Gold's scarcity made it a valuable asset, just as ATP stores energy within its phosphate bonds. The one key difference lies in decentralization. The gold standard was controlled by central governments and authorities regulating its issuance, whereas ATP operates in a decentralized manner. Each cell independently manages its own energy supply. So why is the comparison relevant? Well, it provides a new perspective on economic systems, visualizing them like organisms that require health, growth, and resource management. The ATP to ADP cycle mirrors how economies regulate money flow, especially under a system like the gold standard. Ultimately, the analogy helps us simplify complex biological and economic systems, showing how both principles ensure efficiency, stability, and sustainability in their respective domains.
And finally, I'll be talking about the decentralized nature of ATP and the future monetary systems. Traditional financial systems operate under centralized control, with banks and governments managing transactions. However, centralization can lead to inefficiencies, bottlenecks, and even economic crises when key institutions fail. Decentralization, on the other hand, distributes control, reducing systemic risk, and enhances flexibility. Blockchain technology plays a crucial role here by enabling secure, transparent, and peer-to-peer financial transactions without intermediaries. This mirrors how ATP enables individual cells to manage their own energy needs, ensuring efficiency across biological systems. Decentralized finance, or DeFi, is revolutionizing the way we handle money. By eliminating intermediaries like banks and payment processors, DeFi allows users to transact directly, reducing costs and increasing efficiency. Smart contracts, which are self-executing contracts on blockchain networks, automate transactions without the need for trust in third parties. This significantly lowers the risk of fraud and increases financial inclusivity, granting access to banking services for millions worldwide. Just as ATP enables every cell to function independently within a larger system, DeFi empowers individuals to manage their own financial resources without central oversight. The future of finance is moving towards decentralization. By reducing reliance on centralized banks and intermediaries, financial systems can become more inclusive and efficient. One potential innovation is energy-backed digital currencies, where decentralized energy production, similar to ATP, could form the basis of monetary value. This could revolutionize the way we think about financial sustainability, mirroring how ATP sustains life through decentralized energy distribution. By integrating these principles into our own global economy, we can create a more stable, resilient financial future. Finally, the lessons from ATP's decentralized energy model provides valuable insights of our financial systems. Just as biological systems ensure efficient energy distribution without central oversight, blockchain-based finance creates a resilient and inclusive economic landscape. By embracing decentralization, we can enhance financial stability, empower individuals, and build a global economy that's more adaptable to future challenges. That is the key part. The future of money can be decentralized, just like the fundamental energy systems that creates life itself. And finally, these are our references.